So we will be doing the experiment after the break. This experiment is on price control. I eventually decided that lecturing about price control is not as helpful as actually showing this directly. Let me show you the market force. So here's the game instructions. So each of you will be joining a group of 5 sellers and 5 buyers. So you'll be one of these. And so you trade to maximize your profits. So the sellers are orange producers selling oranges. The consumers are hungry. They want to buy oranges. So here's your seller screen. On the left, you have the cost of the orange and then your earnings. On the top right, you have the past transactions. So you see here that the last orange was bought at 111. And then you can either slide the bar here and hit ask, or you can choose to sell at the highest bid. So here are the highest 3 bids and lowest 3 asks. So you can sell at the highest. That's taking the other side's offer. So if you hit sell highest bid, then you will be selling at 103. And your profit, of course, is whatever price you pay minus the cost. So here it's 65 cents. So that will be your profit. And if you're a buyer, similarly, you can slide this and decide how much you want to bid. So buy 104. Or you can say, maybe I should just take the other side's offer. So there's a sell 87. So you can decide to buy at that price. So basically, this is the computerized version of the classroom experiment we saw last time, where I was here taking all these offers, buy 50, buy 60, or sell 100, sell 89, and taking the other side's offer. All right, and the buyer's profit, or the consumer surplus that we just saw, is the value of the buyer, that's on the top left, minus whatever price you paid. Okay, so bids are the buy offers and asks are the sell offers. So these are the past sales for the whole market and current bids and asks. So to trigger a transaction, if you hit buy at lowest ask or sell at highest bid, then there will be a transaction. So if you place a bid that's higher than the lowest outstanding ask, that's basically taking. If you place an ask that's lower than the highest bid, then that also is like taking the other side's offer. Actually, I think you guys saw this last time when if there was a sell 100 and then somebody says buy 101, then that's basically taking the sell 100. So after you bought or sold an orange, what happens is that as a buyer, the value of the next orange will be lower than the previous orange. And for the seller, the cost to supply a next orange will be higher than the previous orange. So we have the law of demand and law of supply working here, even at the individual level. Okay, let's do a little quiz. As a seller, if you ask for 124 over here and somebody accepts that, what is your profit? So here, actually, I already gave away the answer, right? Yeah, you get it. 124 is your ask. Somebody accept that. So that's the price amount you earned for this transaction. But then your cost is 65 cents. So the profit is 59 cents. And it is indeed on the screen as well. And okay, so suppose you're a buyer now. What if you hit buy at lowest ask? Now what is your profit? So your value is 138 at the top left. And then if you buy it at the lowest ask, which is 87 cents, so you can do the calculation and find it's 51 cents. So your job is to maximize your own profit. There will be an exchange rate, I think it's 1 to 30 to the actual points in the class. And so you can ask yourself, what's the prediction of supply and demand? And we'll see if that is correct. All right, we will start the experiment. We'll start round 1. Okay, I think most group have finished. There are people who are still in the round. They have joined late. But I think I set the time limit to be 3 minutes, so everybody should be coming back now. So that's finished. Yes, it's finished. So we can actually see the results. Let me show you the results instantly on the screen. So this is the supply-demand curve. And this is group 1. You can see group 1 at the very end. There were 4 transactions and converting towards the equilibrium price of 112. And this is group 2. Remember, this is the supply-demand curve. Group 2, there were a lot of transactions, starting too low, but then fluctuating, converging towards the equilibrium price. Here we have group 3, but only 5 transactions, but close to the equilibrium as well. Group 4, only 3 transactions, but almost all spot on. Hey, you guys are so good, but where are the other transactions? Group 5 has 1, 2, 3, 4, 5, 6, 7, 8, 9 transactions. Also pretty close. Oh, group 6 has like a lot of transactions. I'm not sure if you guys made money. Somebody bought or sold at a loss. But in the end, you're still converting towards the equilibrium price. That's something that's amazing. This one's pretty crazy, group 7. I think the later ones had add robots in it, so I'm not sure if these are real or are these robots doing something crazy. Okay, let's go back to the slides. So we went through the first part, which is the market forces working. So what was the equilibrium price and quantity of your market? Here I'm showing you the supply-demand schedule. We just went through chapter 7, so you should know that each step is the marginal buyer's willingness to pay or the marginal seller's cost. And so the equilibrium price is 112 with the equilibrium quantity of 13. So you guys, some of your trades may not have realized there was still gains from trade that you could have bought or sold. But of course, it's the first time. So if you play the second time, then things should be better. So now we're going to go to price control. First, we're going to have a price floor of 50 cents. What does that mean? A price floor means that that's the floor, right? So you cannot go below the floor. So you cannot have a price below 50 cents. Question, what would happen? Well, we'll have to find out. So, okay, so everybody's in, and that should start. Okay, so a lot of groups have finished. Oh, there's one group that still has not finished, so we have to wait. But most groups have already finished. Okay, the last group has finished, so I'm going to close this session, and we can look at the results. So, okay, what happened? What is your impression? Well, okay, so here, this market has a supply-demand schedule that looks like this. So the equilibrium price is 75 cents with a quantity of 4. And the price floor of 50 cents is not binding. So, well, things are not affected. So if you look at this, so this is group 1. There were 5 transactions, pretty much very close to the equilibrium price of 75 and not affected by the price floor. Here's group 2. So somebody started at 50, but then people were, the prices quickly converged to the price of 75, and it was not affected. Here's another group. Prices started high, maybe because last time was different, but not affected. And it converged to the price of 73 that was transacted here. And then here's group 4. 4 transactions, almost all very close to the 75 cents. And here's group 5. Ooh, group 5 had a lot of transactions. I mean, you guys had fun. I'm not sure if you earned more money for that, but yeah, I mean, somebody might have traded at a loss or did not earn that much. But okay, in the end, prices are still reasonably close. The last transaction price is 70 cents, not that far from the price, the equilibrium price. Group 6, there were some transactions up and down, but still not affected by the price floor. Group 7, ooh, something interesting happened at the very end, where prices started out very high, but then quickly converged to the 75 equilibrium price, not affected by the price floor. And then here's another one. Prices started relatively high, but then converged to 75. All right, so that's for the price floor of 50. Now we're going to go back and say, what was the equilibrium price and quantity of your market? Yeah, so it's this one. So you just saw, this is the market schedule. And the price floor of 50 did not really affect anything. Now we're going to change this to have a price floor of $1, 100 cents. And I think I didn't change the supply-demand schedule, so it'll be the same one as before. So let's go on to the next one, and let's go. Okay, I see most of you have finished, so let's take a look and show the results. Okay, so what happened this time? Well, so now we have the problem is that the price floor is binding. You cannot trade below 100. So what that means is that you would have a shortage. So group 1 had a lot of trades above 100. You guys had fun. You lost points, but if you don't care, then maybe you don't care, right? Let's take a look. Okay, so group 2, so only 3 transactions, all exactly at the price floor of 100 because the price control is binding. Group 3, 3 transactions only at the 100. Group 4, okay, so you have 5 transactions, but all very close to the price floor of 100. And then, ooh, so yeah, this group also had a lot of fun, but still the price control was binding. And then this group had 4 transactions, all at very close to 100. One was above, this one was 110, so slightly higher. And the last group had only 3 transactions as well, and this had only 2 transactions. Okay, so let's go back to the presentation. So what happened with the price floor of 100? The key thing here is that now the equilibrium price is not available. So you're hit by this price floor. And so you have way more supply than demand. So you have a surplus or excess supply. And actually quite a lot of groups got the equilibrium quantity of 3 because that's where it's stuck. Okay, so now we're going to do price ceiling, but price ceiling of 50. So we did price floor of 50 before. Now we're going to try price ceiling of 50. So again, let's just begin. Everybody's here, so we can start. This is one of your groups. You see that all the transactions are pretty close to the price ceiling of 50, but there are a lot of people who still want to buy, but nobody wants to sell. Okay, so because all of the groups have finished, so now I can show you the results. So the key thing here is that compared to the original supply-demand schedule, now the price ceiling of $50 is binding. So you're not allowed to trade above that. So the original equilibrium price is not possible anymore. And so, yeah, so you have very few transactions, but all very close to the price ceiling. Same here, although quite a few transactions here. And then, a lot of transactions over here at the very beginning, and that's it. So, yeah, so here you see the market is stuck here because of the price control. Actually, I can show you the scoring board. Oh, somebody got 112. That's impressive. Let's see. Oh, a lot of people got negative. Okay, you're going to lose points. It's your choice, right? Okay, that's fine. I mean, you're going to lose points. Some didn't trade. That's okay. But we have winners here. All right. Okay, so let me go back to the slides. So the key thing here is that we're thinking of, like, if you think of the orange market, you could have, say, there's a natural disaster. In the US, there will be hurricanes. In Taiwan, you have typhoons. And so, because of this natural disaster, let's set a price ceiling of 50 cents. And so, actually, you already see this kind of price gouging in the news. And what happens is says we are out of stock because it's all gone. So we already saw this ceiling. And in this case, because the $50 is binding, so the equivalent price is stuck at $50. There's excess demand, there's a shortage, but too bad. All right, so the difference is here. So when you have a price floor of $50, it's not binding because it does not rule out the original equilibrium price. And so it's business as usual. It's like without that. So here are some of the previously that different groups would convert to different things. But when the price is binding, in this case, the price floor was 100. So that was what happened. So people were stuck at 100. Oh, this is last year, but there's another group that also decided to trade a lot at a loss. That's fine. And then when you have a price ceiling of $50, that was the last round that you just played. So you can see this is what happened last year. Some of the groups had fun, but most of them just stick to the $50 thing. The key thing for price control is this. So a price ceiling means that you cannot sell above this price. But if it's above the original equilibrium price, it's not binding. So no problem. In this case, it's business as usual. But if the price ceiling is below the equilibrium price, then now it's binding. And in fact, the quantity supplied is less than the quantity demanded. So you have a shortage. And it's forced by the price ceiling. Because if there is no price ceiling, then this excess demand would bid up the price. And so when prices go up, converting towards the equilibrium, the shortage will disappear. So to conclude, if the ceiling is above equilibrium, it's not binding. It has no effect. If it's below the equilibrium, now you have excess demand or a shortage. And so that creates problems. We see this every time there's a natural disaster. These supplies, we have a shortage. Last year, when the pandemic just first started, masks were in shortage. And then you see that, I remember that was during the Chinese New Year break. So I went to a local Baoya, a drugstore, and then I realized that all of the masks were gone. I immediately went back home and tried to order online. I was lucky to get the last batch because the next day, these online stores basically said, don't call me, don't message me. We're all out of stock, everything's gone. Yeah, that's what happens when there's a shortage. For a price floor, so this means that you cannot sell below this price. If it's below the equilibrium, it's not binding, no effect. Business as usual. But if it's above the equilibrium, Now quantity demanded is less than quantity supply. You have excess supply or a surplus. And so that's when there's too much of something. All right, so that's the end for price control. And so we can go to the next topic on taxation. Now, suppose the government decides to put a 32-cent tax on the seller of oranges. So for each orange you sell, in addition to whatever price that the seller can get, the seller will have to pay 32 cents to the government. Let's see what would happen. Okay, I think let's still go through the original one without taxes because I have changed the supply-demand schedule again. So the first one is without taxes. So everybody's here, let's just start. Okay, so this is the round one without taxes, and we'll contrast that with taxing people. Okay, I think most groups have finished. What do you think the demand schedule was? Yeah, because it's different from the price control one. So let's see if we can take a look, or should we just have you guys guess? All right, so let's look at the results. So this is market equilibrium is 112 and with 13 transactions. And so here is group one. You guys already know the answer, so you were spot on. Group two started out with a price that's way too low at 75 cents. That's the original one, but eventually started to gradually converge, and the last price was 109. So you guys discovered that it's a different market. Group three, very interesting. Try to stick at 75, and the time ran out. Group four, prices started out pretty wacky, but then converged towards the market equilibrium of 112. Group five, pretty much spot on. You guys knew that. And then group six started out low, but then converged toward the equilibrium price. Group seven fluctuated a bit, but then converged to equilibrium price. And here's group eight. Okay. So that is without taxes. Now we're going to add the tax. So there's a 32-cent tax on the seller, and we'll see what happens. Okay, so everybody has finished. So let's go to the results. So here, the key thing for the tax is that you're shifting the supply curve up by 32 cents because it's as if for whatever quantity supplied, now instead of the original cost, the seller is incurring an additional cost of 32 cents. So the equilibrium quantity would drop and the equilibrium price would go up. So here the equilibrium with seller tax is $1.24 and the equilibrium quantity is going to drop to 9. And so here's the new equilibrium, and so group 1 is converting towards that. Here's group 2, also spot on. Group 3 started out crazy, but then converting towards that new equilibrium. Group 4, starting low, but then converting up. Group 5, again converting towards equilibrium. Group 6, oh, this one's crazy. Somebody bought at $3. Okay. I mean, it's your points, right? It's your money. I'm neutral on that. And here's group 7, and then group 8, and group 9. All right, so that's the tax on sellers. So what happened? So here we're shifting the original equilibrium towards this one. So the equilibrium price increased to 124, equilibrium quantity dropped to 9. And we do see people converting toward the price like that, although some groups didn't complete all the possible transactions, and some prices were actually slightly crazy. Yeah, so question, how much did the sellers actually earn after tax? So the equilibrium price is 124, but remember, the seller has to pay 32 cents in taxes. So the seller only earned 92 cents. That's the net. And okay, so now suppose the government says, maybe we should try to do something different. Let's tax the same amount, 32 cents, but on the buyers instead. Now what's going to happen? So now in this part of the experiment, we will go to taxing the buyer. Okay, everybody's here, and please join. Okay, so let's look at the results. This is round one. So the key thing here is that initially you have buyers have a value, have a willingness to pay, but because now you need to pay the tax, so your willingness to pay on the market will be lower. Initially, for this quantity demanded, your willingness to pay is $1, but now because you need to pay 32 cents for tax, for the same quantity demanded, you're only willing to pay the seller 68 cents. So you're shifting the demand curve down by exactly the amount of the tax. And the equilibrium price after with the buyer's tax is 92 cents. The equilibrium quantity is 9. So let's take a look at your results. Ooh, so group 1, even in round 1, is pretty close. Group 2 is almost all spot on, exactly 9 transactions. Group 3, again, pretty much converging towards there. Group 4, Group 5, 6, 7, and 8. Let's see. Actually, we can go to group period 2, but I believe things are not that much different because even in round 1, you guys already converge pretty well. On the left, the first graph here is before tax. The equilibrium price is 112 and the equilibrium quantity is 13. That's the default setting. But then after tax, so you have this, you're shifting the demand curve down by tax amount of 32 cents. Equilibrium price drops to 92 and equilibrium quantity is 9 units. And how much did the buyers actually pay? Well, the buyers bought at 92 cents, but then they have to pay the tax of 32 cents. So a total of 124. So the interesting thing, let's now start to discuss this. Before tax, well, so we have the P0, Q0, that's the equilibrium. But with the tax, if you tax the seller, you're shifting the supply curve to the left or shifting it up. And so now the price that the seller received is PS over here, but then there is this tax that the seller has to pay to the government. And if you are taxing the buyer, so you're shifting the demand curve down by the tax amount or shifting it to the left. Now the buyers are paying a PB, but then in addition, they still have to pay the tax. And so let's take a look. In the original equilibrium, it was 112. But when you tax the seller, the equilibrium price becomes 124. That's the PS. But then if you minus the 32 cents, then the sellers only receive 92 cents. And 92 cents is exactly the equilibrium price when you tax the buyer. So here, so regardless of you're taxing the buyer or the seller, it happens that the sellers are always going to receive only 92 cents. And when you tax the seller, buyers are paying the equilibrium price of 124, but the sellers are not receiving all of that because the sellers have to pay the tax. But when you tax the buyers are paying not only the 92 cents in equilibrium price, but also 32 cents in taxes. And you add this up, it's exactly 124. So the buyers are actually paying the same amount when the government is taxing the seller. So the fun thing here is regardless you're taxing the buyer or the seller, using this per unit tax, what you're getting is that the sellers are always receiving the same amount and the buyers are always paying the same amount. And the difference is exactly the 32 cents of tax that the government charges. So the tax burden, or who is paying this 32 cents, is the same regardless of who the government is taxing. So it's not like, say, oh, so these evil companies, let's tax the evil companies. Well, that may or may not work because the tax burden is shared across the buyers and the sellers. And actually, it depends on the elasticity. That's what we learned in chapter 5. Because the tax burden will fall on the party that has inelastic demand or supply compared to the other side. So the effect of the tax is that it creates a wedge between what the buyers pay and what the producers receive. And the elasticity basically determines who shares a bigger burden of this tax. So the key takeaway, so the tax incidence is the way that the burden is split between the consumer and the producer. And it then does not depend on who the tax is placed on, but by the elasticities of supply-demand curves. So one thing that we can use, we just learned about consumer surplus and producer surplus and total surplus, is we can talk about why economists think taxes are bad. That's because of deadweight loss. Let's take a look. When you tax somebody, buyers pay more, sellers receive less. And the difference between how much buyers pay and how less sellers receive, this difference is the tax. But we already know that it doesn't depend on you tax the buyer or the seller. You got the same result, but here's the problem. Buyers are paying more, so they're buying less. Some of the marginal buyers decide not to buy anymore. But if sellers are receiving less, they are going to sell or produce and sell less. So there, things could be bad. Let's take a look. So this is the original equilibrium, P star and Q star. And you have the upper triangle is the consumer surplus. The lower triangle is your producer surplus. Without the tax, you're maximizing total surplus at the equilibrium. But now, suppose you tax the seller, so you're shifting the supply curve to the left. You have exactly the size of the tax. So the amount sellers are receiving and the amount buyers are paying, that wedge is the tax. And so this purple rectangle in the middle is the tax revenue. That's the amount that goes to the government. And so, of course, it's size of the tax multiplied by quantity. And the key thing is this. You have this, what we call Harburger triangle, the deadweight loss of taxation. So this is the loss in terms of total surplus because those transactions are not traded. So the new equilibrium quantity is lower than the original equilibrium quantity without taxation. And so there you have a triangle of total surplus that's lost. Without the tax, so these transactions will be realized. So these gains from trade will be added to the total surplus. But because of this tax, the equilibrium quantity drops. And so these transactions are not realized. So when you have a surplus that's greater than the tax, so if the surplus is greater than the tax, then total surplus does not change. You're just transferring this amount to the government. But if you have a surplus that's less than the tax, then the trade does not happen. So the producer surplus and consumer surplus is zero. So basically, up to the new equilibrium quantity with taxation, well, the sellers are receiving less, buyers are paying more than the original equilibrium. So consumer surplus becomes smaller, producer surplus becomes smaller. You have this rectangle in the middle, that's what the government is taking away. But at the very end, so beyond the new quantity, you have this loss of trade because the surplus there is smaller than the tax amount. So consumers and producers are not going to trade. And so then their producer surplus and consumer surplus all go to zero. They're not going to trade. And government is not going to receive any tax either. So that's where the deadweight loss is coming from. All right, so let's take a look at the experiment. So we had a tax size of 32 cents. And you can ask, how big is the revenue? So 32 cents, and the equilibrium quantity with taxation is 9. So 9 times 32 cents. So the government actually gets 288. So there is a gain in terms of governmental revenue there. So you can actually compare before and after. Before, the consumer surplus was 2.5, producer surplus was $4, total surplus is $6.50. Now the tax revenue, the government is taking away $2.88. You can see that consumer surplus shrinks to $1.20. Producer surplus drops to $1.90. And the total surplus, even if you add back the tax revenue, it's still only roughly $6. So you get a deadweight loss of 50 cents in our experiment. Okay, so here you can look at the potential surplus. The total gains from trade is the 650. The tax revenue is this purple part, 288. And consumer surplus is now shrink to 120. Producer surplus is shrink to 190. And what's remaining is your deadweight loss, which is the 50 cents. These are the gains from trade that are not realized because of your taxation. Okay, so the problem here is because now because of this tax, you are forcing the buyers to pay more, the sellers to receive less. And so the quantity that's transacted is now reduced, and that's where the deadweight loss is coming from. So it's a surplus that's not realized or gains from trade that could have happened when there's no taxation, but because of the tax, now these trades are not happening. So the gains from trade that could have realized is not realized. And so neither the consumers nor the producers, not even the government, is getting any of this. So at some sense, this is what the economists care a lot about, because these are gains from trade that could have been realized, but because of these bad policy, and so it's not realized. If you think of it, earlier we talked about the kidney swap. That's precisely a gains from trade that's not realized. I could have donated my kidney to your husband, and in exchange that you donate to my wife, and both of us would be better off, both families would be happier. But if we ban that kind of kidney swap, then this gain from trade would not be realized. That's why economists care a lot about this, because, hey, I mean, there's mutual benefits here. Everybody will be better off. Why are we preventing this transaction from happening? In the case for taxation, it's the same thing. Because of this tax, so now buyers have to pay more, sellers receive less, and so the marginal buyers and marginal sellers decide, I don't want to trade anymore. And that's a loss for the whole society. Okay, and how is this determined? Well, it depends on the elasticity. So now you see why elasticity is so important. So elasticity determines the deadweight loss. So let's take a look. So suppose you have an inelastic supply. So compared to the original case, you have inelastic, you have a very steep supply curve. What's going to happen? Ooh. So first, you get smaller deadweight loss. Compared to the original deadweight loss, it's smaller. Because the new equilibrium quantity, it's still smaller than the original equilibrium quantity, but the difference is not that big. So in that sense, it's good. However, compared to that, if you have an elastic supply, now you have a bigger deadweight loss. And the key thing here is that because if the sellers are sensitive to prices, when the government is taxing this product, these sellers will leave the market. More sellers will leave the market because they're sensitive to this price. And now because of the taxation, sellers are receiving less than what they could have received. And so if they're sensitive to price, then more sellers would leave the market. And so more potential gains from trade that's not realized. If they're not sensitive to prices, you have inelastic supply, then the loss of the gains from trade would not be that severe. Same thing on the demand side. If you have inelastic demand, again, you have smaller deadweight loss. If we have elastic demand, then you have more deadweight loss. So the key thing here is elasticity. If you have inelastic either supply or demand, you would be getting less deadweight loss, even if you tax this market. But if you have more elastic either supply or demand, you would have larger deadweight loss. Okay, so the key takeaway. Deadweight loss is the decrease in total surplus because of the foregone production and consumption, foregone transactions, because this tax distorts the market. And so it's the cost to the society of a tax or other market distortions. And it depends on elasticities and also the size of the tax. So that determines how big the deadweight loss is. All right, so that's that part. And so I think I can go back to the lectures. Thanks for joining this talk.